Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 2606, find the substring with maximum cost. So basically you just want to find the maximum sum of a substring in S. Basically, there's going to be two options here. So if the character that we're looping through exists in chars, then it's just going to be the same location, which probably should indicate that these are going to be unique. So chars are not going to have any duplicates. And then otherwise, if it's not in chars, then it's just going to be the alphabetical value, which A is 1 and Z is 26. So you can think of it like the index plus 1, and then just find the largest subarray sum. So let's do exactly that. So let's just go ahead, loop through S, and let's actually do some pre-processing to make our life easier, because if we want to check if a value is in chars, we can probably just, since we know they're going to be unique, then we can just use a dictionary. So let's call this CD is just going to be a dictionary. So for I, C to enumerate chars. So CD of C is going to be equal to I, so we can get the value of where this character, so D is at index 0 in chars. And then let's do the same thing for our letters that we're going to build. So letters is just going to be all the alphabetical letters in order, so A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so now let's call this another D. So now we're just going to map the actual letter to I plus 1, right? Because that's supposed to be 0 plus 1 is 1, 25 is 26, so index, we're looking at the normal length. Cool. So now let's go ahead and loop through S and find the maximum substring cost, right? So then we can just say, so the character is S of J. So again, if the char is inside of CD, because this is a hash map, this is going to be O of 1 lookup, then we can just go ahead and add the actual value of the same index. So we can just say values of CD of char, which is just going to give us an index because the value is the character, which is the key. And otherwise, then we're just going to add D of CD of char. And then again, we can just take the maximum subarray sum of each subarray and then return answer at the end after we've traversed all subarrays in n squared time complexity, right? So let's run this. Okay, so it's not there. Oh, we just call this char. Okay, submit it. It doesn't exist. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Try this again. Submit it. And so what you'll find is this is going to time out because it's n squared. So there's a better solution. If you know how Cadane's algorithm works, then it's actually pretty straightforward. Basically, we just keep looping through because this can be negative, right? So you can think of it as similar to that maximum subarray sum, which is Leetcode 53. And then instead of looping through every subarray, again, if whatever the value is negative, or if the subarray sum is negative, then we can just set it to 0 because we're looking to maximize the result. Any number plus a negative number is probably just going to make it worse, so we can just reset it to 0 because we might as well just not pick that number is the idea behind it. So basically we want to start with a fresh slate before we add the value. And again, the value, if S of I is inside of CD, then the value is just going to be values of CD, or yeah, so values of, let's call this char again, CD of char. So otherwise, the value is just going to be D of char, right? So basically, we're starting with a clean slate, and looks like there's some bugs here. Okay, so... Okay, and then we're going to want to take the maximum of the current subarray sum, because again, let's say you have -1, -2, 1, 3. We're better off not picking this number and skipping it, right? That's the dynamic programming part. So because if we add this, then that's actually worse, because if the subarray sum is less than 0, we're better off just discarding this whole thing and starting fresh instead of adding everything, right? And that's kind of the idea. So 1 minus 2 is -1 plus 1 is 0. So it's always better to start with 0 is the idea. If we hit a negative number, or if the subarray sum becomes negative, the overall thing is negative, then we can just start from a fresh slate. So, and this takes care of the negative numbers and turns the Keim complexity to O of n instead of n squared. So let's run this, submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.